Okay, everybody. So I gave you a couple notes on the binomial model that we missed in class. I went over how I look at some of those binomial examples, and now I wanted to go over what I intended to cover in Thursday's class, which is some of the hardest part of the unit is to determine when to actually use the appropriate formulas for the models. So what I want to go over is when we're going to actually be using each one of these probability models. Now, we've learned so many formulas. So what I want to do throughout these problems is remind us of those important formulas. So here's how I was going to do this. I was going to have everybody take a moment and read through the examples on pages 20 and 21 to try to figure out if the examples are binomial or not, as said in my note to everybody yesterday. Now, I am going to walk through each of them and point out how I know what to do for this problem based on the wording in the problem, or how I know how to set something up, okay? Once I get to that point, if there's a specific formula I need to use or I think that needs to be seen again, I will likely do the entire problem, okay? So this may be a little bit of a long video, but we're on pages 20 to 21, and I'm just trying to give you guys as much help as possible while I don't get to see you for a week, okay? So let's read this problem together. On awards day, Jasmine has an 85% chance of winning the award in English and a 4 out of 5 chance of winning an award for athletics. What is the probability that she wins both? So I'm going to start with the probability she wins the English award is 85%. So let's convert that like we know we have to 0.85. And then she also has a separate probability of winning an athletics award, which we'll call A, and that's 4 out of 5, which if we stick that in the calculator gives us 0.8, okay? Now it says, what is the probability she wins both? So both means and to us. So they are asking us E and A. She wins the English and the athletics award, okay? So what we need to determine here is whether or not those two things are independent from one another. Now, someone's performance in English has nothing to do with their performance in athletics. So we can simply use the multiplication rule because these two events are independent. So English and athletic award are independent, okay? So I'm going to replace each of these with the values that we have above. So that's 0.85 times 0.8, which if we stick that in the calculator gives us a probability 0.68 that she gets both awards. Okay. Now, let's read the next problem together. Emily has a habit of losing her keys. She estimates there is a 0.2 chance she left them in her office, a 0.35 chance she left them in her purse, and a 0.15 chance she left them on the kitchen counter. What is the probability her keys will be in none of these places? Okay? So she's got the probability that they are in her office, right? So office, that's 0.2. She's got the probability that she left them in her purse. That's 0.35. And she's got the probability that she left them in the kitchen, which is 0.15. Okay? So the idea behind this problem is that these are disjoint events. Emily cannot possibly leave her keys in the office, her purse, and the kitchen all at the same time. So if these are the three options that were given, then her leaving them in none of those places would be none of those would be 1 minus the probability of the office or the purse or the kitchen. And the word or for disjoint events implies that we can actually add these probabilities together. Okay, and if we add those, we get 1 minus 0.7, which leaves us with a 0.3 probability she left her keys in none of those places. Okay? Okay, so now on to 3. Okay. New spark plugs have just been installed in a small airplane with a 4-cylinder engine, i.e. uses 4 spark plugs. For each spark plug, the probability it is defective and will fail during the first 20 minutes of the flight is 1 out of 10,000. And then it asks about the probability that none of them will fail, or the probability that at least one will fail. Okay? So I want us to think about the wording of this problem. There's a few things that I see in the wording. First of all, the spark plugs either fail or they do not fail. So this is a binomial model. Okay? Now, we're talking about the spark plugs failing. So we need to think about how many spark plugs there are, because that's how many trials there are. So we are told that there are 4 spark plugs, i.e. 4 trials. And the probability of one failing is 1 over 10,000. Okay? Now, I'm actually going to leave the answers to A and B up to you for this one, since we just did those 2 binomial problems. So for these, you can see the solutions to page 20 on Canvas. Okay? Let's move on to 4. Likely, if it's binomial, I will not go over it, except I say that and then I read the next problem and I kind of want to. So we'll see. At a local university, 54.3% of incoming freshmen have computers. It's probably outdated. If 3 students are randomly selected, find the probability that. Okay, so now, 54.3% have computers. They either have a computer or they don't have a computer. So this is a binomial model. We're selecting 3 students at random, and the probability they have a computer is 0.543. So we are going to do this one real quick. Probability that none have computers. Well, that's exactly 0. So that's a binom PDF where I have 3, 0.543, and 0 successes. So 0 computers. That's 0.0954. Okay. B. Probability of at least 2. Now this is equivalent to 1 minus the probability of 1 or fewer, right? At least 2 is 2 or more. So we have to get rid of 1 or less. So the way that we do that is we would take 1 minus the binom CDF with 3 people, 0.543, and 1. So this takes 1 and 0 away, and we're left with only 2 or 3. Okay? And if you stick that in the calculator, you'll get 0.5643. Okay. And then I'm going to skip part C, but all have computers is the same as exactly 3. So this is a PDF at 3. Okay? I'm going to flip to the next page. Oh, nope, just kidding. I skipped number 5. Let's go to number 5. Okay? 5 says, a box of candy has 6 chocolate-covered cherries, 3 peppermints, 2 caramels, and 2 strawberry creams. So altogether, it has 6 plus 3 plus 2 plus 2 items, which means that it has a total of 13 items. This is the sample space. So if we have a probability example here, sorry guys, then we will use 13 as the denominator. If a piece of candy is randomly chosen, find the probability of getting a caramel or a peppermint. Caramel or peppermint. Well, can we get a caramel and a peppermint at the same time if we only choose one? No. So we can add the probability of a caramel plus the probability of a peppermint because these are disjoint. Okay? And it says that there are 2 out of 13 that are caramels and 3 out of 13 that are peppermints. So altogether, the probability is 5 out of 13. Not bad. Okay, let's look at number 6 on the next page. A survey found 77% of bike riders sometimes ride without a helmet. 4 bikers are randomly selected. Find the probability that at least 3 do not wear a helmet. Okay, so this is a binomial. They either wear the helmet or they do not. We are selecting 4 bike riders at a time. That's my dog, and we have a probability of 77% that they ride without a helmet. Hey, Jackie. She's just saying hi. Okay, so probability that at least 3. Let's look at the language here one more time. I know this is binomial. I said I would skip it, but at least 3. That would be the probability of at least 3 is 3 or more. So that's 1 minus the probability of 2 or fewer. So very similar to what we did on the other side. 1 minus the binom CDF, because we want to take away everything below 2. This is 4, 0.77, and 2. Okay, and if you plug that in, we get 0.7715. All right. Let's see. I would like to set up the diagram for number 7 and then leave the questions up to you, and then we'll do, actually no, the tree diagram usually goes really well. I want you to do 7. Try on your own. Let me talk about why I know it's a tree diagram. Assume 85% of my statistics students studied for their test. Suppose 35 of those who studied get an A, but only 5% of those who didn't study get an A. So right there, we're given the first thing they did. They either studied or they didn't study. So studied or didn't study, right? And then we have they got an A or they didn't get an A. Okay? So go ahead and fill that out and try to answer those questions. Again, see the solutions to page 21 online. Okay, one more. I promise, only one more. Assume 85% of my statistics students completed their Unit 2 review. 35% made a study guide and 22% did both. Is that you guys? Okay. So look, we're given completed their Unit 2 review, 35% made a study guide, and then some people who did both. So they give me P, basically P of A, P of B, and P of A and B, right? So this means it's a Venn. Okay? So together we're going to make a Venn diagram. We're going to assume that there are 100 people because we're given the percentages here, like the one time that we did in class. Now we have to start in the middle, so let's make sure that we make our 2 circles here. 1 circle here, okay? Review, study guide, okay? So this is 22% did both, so we make that 22 people. And then it said 85% did the review, so this becomes 85 minus 22 because it doesn't say they only did the review. And then this side, it says 35% made a study guide. So that does not say only a study guide, so we have to take into account the people who did both, which means that there are 13 people who only made a study guide. Now, this number outside is found by doing 100 minus, and then those numbers added up. So 63, 22, and 13, and we get 2 people who didn't do either. So then we read the questions. What is the probability somebody did not complete the review and did not make a study guide? So no review and no study guide is this number outside. So that's 2 out of 100 or 0.02. Okay? And then one more. Given that a student completed the review, what is the probability they did not make a study guide? So let's read carefully. Given they completed the review, right? They did the review. What is the probability they did not make a study guide? So that means we need the numerator to be no study guide, but they did do the review, over the probability that they did the review. Okay? Now, I'm going to move over here a little bit so I have room, because this number didn't do the study guide and did the review. Okay? So they didn't do the study guide means that I can cover up this whole study guide circle, but they did do the review, so they have to fall in this circle. So the numerator here is 63. And then we need to think about all of the people who did the review here. So I'm going to do this as an addition problem. It's these 63 people who only did the review, plus these 22 people who did the review and the study guide. So it was that original 85 we were given at the beginning. 63 over 85, which is 0.7412. And those are the practice problems for probability. Hopefully you found that to be helpful.